Here is a problem from chapter 3 in the OpenStax book. This is number 22. Just going to solve it. It's not the best problem, but it'll give us a lot of chance to practice. So the question says that there's a farmer and there's a fence, and the farmer knows 3 of the sides of the fence, and they want to find that 4th side, D. So this is A, B, C, and what would be the magnitude, the length of that fence, and the angle, and they give you all these distances and angles. Let's just get to it. So this is a vector addition problem. As you can see, they're drawn as vectors. So what we want to say is A plus B plus C plus D equals 0. And those are all vectors, and yes, there is such thing as the 0 vector. So the 0 vector is different than 0, and in fact the 0 vector looks like this in 2 dimensions. Remember, we can write a vector as an x component plus a y component, and that's what we're going to have to do for all of these vectors. And so with that, we're really going to get 2 equations. We're going to get an x equation and a y equation, and we can use that to find the magnitude of D and the angle. Let's just start. So the first thing I want to do is to write all these vectors as components, and I'll write them. See, how low can I go right down there? I'll try to write it over here. So let's just start with vector A. Remember this vector A, and I put this to start at the origin just to make it look a little bit easier, but it doesn't really matter, right? You can put these vectors wherever you want. As long as they have the same direction and length, it's the same vector. So here's vector A. I want to write that as a sum of vectors in the x direction and the y direction. So that's AX, x hat, and that's AY, y hat. So if I have that right triangle right there, I know this length is 4.7 kilometers. I know that angle is 7.5 degrees. So I can use that to find the x and the y axis. Now, you definitely want to think about your sines and cosines, right? Sine is opposite over hypotenuse, theta. Cosine of theta is adjacent over hypotenuse. So in this case, the opposite side is going to be my component in the vertical direction, so it will be y. But be careful, don't just say sine is vertical. That's where you're going to get in trouble, and you'll see that in a little bit. So I can write the vector A. I'm just going to write it out in numbers, which I don't normally do, but it's going to be the magnitude 4.7, and there are units. I'm going to drop the units just to make things simpler, times the x component. I'm going to use cosine of 7.5, because cosine is going to give me the adjacent. So it's going to be cosine of 7.5 x hat, and then this is in the negative y direction, so I'm going to say negative 4.7 sine 7.5 y hat. And we'll write that as a number because I'm going to do that in a little bit. But let's do that for all the vectors first. Okay. So now it is possible, and maybe you've done this before, you could always measure from the positive x-axis and it should give you the correct sign. But I wouldn't do that. Just look at the picture, look at your triangle, and find out which side's opposite, which side's adjacent. Is it positive or is it negative? Boom, there you're done. Okay. Now let's do B. So B is this vector right here. So I'm looking at those components. Now you notice again, well, not again. In this case, if that's my angle, this is my adjacent side to the triangle. So the adjacent side is going to give me cosine, but that's going to be the y component. Here, this is the opposite side in the x direction. But that's in the negative x, so it's going to be negative. So I can write this as negative. It had a length of 2.48. Sine of that angle, 16 degrees, x hat. And then the plus 2.48 cosine of 16 y hat. And then finally C, here I have, there's my triangle. My adjacent side is the x component, but it is in the negative direction. So it's going to be negative 3.02 cosine 19 x hat. And then this one's in the the positive y direction, so plus 3.02 sine of 19 y hat. And again, we do not know the d components. We're going to find those. Okay, so I can write, if I want, and I do, d is dx x hat plus dy, that's a y hat. But I don't know dx, I don't know dy. Okay. So let's write these as numbers, because I think that'll just make everyone a little bit happier. They're just numbers, right? They look complicated, but it's just a vector number. So I'm going to write here, I'm looking to make sure I'm not out of bounds, a. Let's just get out our handy dandy calculator and calculate this. So I gotta stand this way. So drop, I get 4.7, 7.5 cosine times. I get 4.66. And that's 4.7, 7.5 sine, negative 0.61. Okay. Next, B. Right here, I'm going to say drop, 2.48, 16 sine, 0.684. I guess it's 6.8. Let's just do it that way. You carry on if you want. I don't really care. X hat minus, right? It was minus, and then plus 2.48, 16 cosine plus 2.38 y hat. Did I do that one right? 2.48, 16 sine. Nope, I messed that up. 2.48, 16 sine times. Okay, just checking. I might have used the previous angle. And then finally, the vector C is 3.02, 19 cosine 2.86 negative. And then 3.02, 19 sine 0.98. Now, those are all in kilometers, just so you know. Vectors can and do have units. I'm just being a lazy jerk and not putting them. But if this was a test, I'd want you to put those units on there. And then we don't know D. D is, I'll write it here. D is dx plus dx x hat plus dy y hat. You have to put the x hat and y hat. You have to put that, right? Because if I just have dx plus dy, that indicates that they're scalars and I could add them together. But I'm not adding them together. I'm adding this vector and that vector to get a vector. And it may seem like a small thing, but it's a big thing, trust me. Big, huge. Okay, so now let's just add together the x components and set them equal to 0 and solve for dx. So I can erase all this stuff now. Actually, I can erase all that. I don't need any of that. Okay, so let's say I'll write it out as 4.66 minus 0.68 minus 2.86 plus dx equals 0. That's what this says, right? Because remember when we add our components, we add the x components together and we add the y components together. So if I add the x components together, I get this equation. I can solve for dx by just putting this other stuff to the other side. Negative 4.66 plus 0.68 plus 2.86, and I get calculator time. I'm not going to do that in my head. So 4 point, that's a 6 negative 0.68 plus 2.86 plus. And I get negative 1.12. So let's write that over here, negative 1.12 x hat. And now I've got to get the y hat. I'm going to do the same thing, but for the y direction. So I'm going to add up all the y's plus dy is equal to 0. I can just skip a step and say dy is going to be equal to negative that, negative that, negative that. So I get 0.61 minus 2.38 minus 0.98 equals, calculator, 0.61, 2.38 minus 0.98 minus, and I get negative 2.75. So this is going to be minus 2.75 y hat. I fit. Okay. So that's my answer. Technically. However, the problem wanted to know the length of the fence and the angle of the fence. So let's just draw that vector. We don't have to. We want to. We don't have to. Okay. So here's that vector d. It goes negative 1.12 in the x direction. That's dx. And then negative this in the y direction. So this is dx, dy, and that's the vector d. Now let's find the magnitude of that. That's not too hard. The magnitude of the vector d, since it's a right triangle, I can use the Pythagorean theorem. It's the square root of dx squared plus dy squared. So it's going to be the square root of 1.12 squared plus 2.75 squared. Calculator. I had those in there, but I'm just going to redo it. Okay, so I get 1.12 squared. These buttons are so tiny. I said 7.5, right? 7.5 squared plus square root. I get 2.97. That's the length of the fence. Now, what about this angle here, theta? Well, there's a couple things you could do. The easiest is just say the tangent of theta is equal to tangent theta is opposite over hypotenuse. That's going to be dy over dx. Don't worry about positive and negatives here because we've already drawn the triangle right here and that angle. So we're not putting in negative values there, even though it doesn't really matter in this case, but use positive values. So that means that theta is going to be tangent inverse of dy over dx. So it's 2.75 divided by 1.12. And if I put that in my calculator, make sure your calculator's in radians or degrees and not radians. So I'm going to say 2.75, 1.12 divided by, and then inverse tangent. I get 67.8. So that's that angle right there. That angle, okay. So if you want to measure it from the positive x-axis, you'd have to add 180 degrees. If you want to measure that from the negative x-axis, you'd have to subtract that from 360. But you could do that either way. And the picture here does help, right? You could even say, okay, it's 67.8 degrees south of west or something dumb like that. But that's what we have. So that's a vector addition problem with four vectors. The end.